All right, hi guys. Here we're going to start another section of notes. We're going to continue with day 2 of 8.3 and 8 through 8.5, which is the rest of the exponent properties. We have a couple properties here that we've talked about before. Multiplying powers, which is where we take the same base, and if it's being multiplied, the exponents add. You'll see there's a little correction to be made here. So these are going to be added exponents. We've talked about power to a power. Power to a power is where we have some base raised to some power, or multiple bases, can be multiple ones. Each one is raised to this new power of n. And when we do that, they are multiplied. You can see m times n here. So that's a multiplication of powers. So adding of powers when we multiply bases, and if it's power to a power, we multiply exponents. All right, and the next one we're talking about is power of a product, and power of a product is where we have multiple different bases inside of it, and it's all raised to a power of n. Each one of these bases are raised to that power of n also. You can see that there's a mistake here, so it should be a to the n and b to the n. It should be the correction there. That's supposed to be an n. Hopefully you guys can all read that. We also talked about negative exponents in the first day. We said that anytime that there's a negative exponent, it tells us to move a position. So in this case, we would take the base, and I signify it much like this, where we move positions. And it will go to the denominator for this one. And we've seen it in the denominator also, and it moves to the numerator. So we're familiar with that one. And the last one that we're going to talk about here is the zero exponent property, which says any base raised to 0 will result in 1. Okay, with the exception of a cannot be equal to 0. That was the one exception for that one. All right, so the two new properties then are the dividing powers and the power of a quotient. Dividing powers was really closely related to, actual inverse to, the multiplying powers property. I'm sorry, multiplying exponents. Okay, where we have multiplication between like bases, we added our exponents. If we're going to divide them, I'm guessing you can go ahead and figure this out. It's going to be subtraction. So we're going to subtract those. But the way that we do it actually matters. Just like subtraction, order matters. So what we're going to do is take a like base, a, and if we want it to end up in the numerator, and I'm just going to put a 1 here to show that it's in the numerator. We would normally not write that. We're going to take and you subtract the exponent in the numerator, so m, and you subtract the exponent of the denominator. Again, order matters. If we want it to end up in the denominator, we do the opposite subtraction. So let's put a in the denominator, and in this case, we would not take m minus n. We're going to take the where it's going to be located in the denominator. In this case, we take that exponent first. So this one's going to be n minus m for the exponent. So depending on where you want it located, it determines which exponent you subtract from which one. So in the numerator, subtract the numerator's exponent from the denominator's exponent. And if you want it to end in the denominator, you subtract the denominator's exponent from the numerator's exponent. All right, and the last one we're going to talk about here is the power of a quotient. Okay, which is very similar to power of a product. Again, product being multiplication and quotient being division. There's an inverse relationship here, which says that when we have more than one base being raised to the power of n, every base gets that power of n. Same thing here, even though it's the same with division. So both of these, a and b, will be raised to the power of m. All right, so that's what we're going to write here. A is raised to the power of m, and b is raised to the power of m. Again, that probably should be written here. So that's a review of all of our rules, plus the two new ones. So now what we're going to do is we're going to jump into some examples down below. So we'll do that in just 1 second.